All right, welcome. Let's go walk through this MATLAB on-ramp. So they've provided a video for you here. Pause this video, watch their video, and come back. And now that you're back, we'll go ahead and proceed. So MATLAB's geared towards mathematicians. We're doing programming in it, but it's designed for mathematicians. So I'm just getting rid of some content that I had here from before. So let's start out with our workspace. Now, this workspace will evolve as we go through it. We have to the right what we have stored in memory. If we store values, we can see what they are at any point in time. And so if we've gone through and done something programmatically to modify a value, you'll see it update to the right. Now, like I said, this interface will change as we proceed through the course. It'll look more like the actual MATLAB. Right now we're just dealing with the syntax and how things work. So we're going to say mathematically 3 times 5. The asterisk is the programming symbol for multiplication. All we have to do is hit the enter key in this version of the interface. And that'll take us down and evaluate the code. Let's hit spacebar, come to the next task. And I'm going to say m equals 3 times 5. So we're taking that and we're assigning it in some value, some variable. So the same calculation that we did previously, now instead of just saying the answer for that calculation is 15, we're taking that 15 and we're storing it in that space in memory. Hit enter, it evaluates it, and it likes what we did, and we proceed. Now we're going to say, take whatever's in M and add 1 to it, and then store that result in M. We hit our enter key, and we've got our M. For some reason this is not updating to the right. We should see M over here, and it may update here shortly. So in task 4, I'm not sure why that's not updating. But in task 4, we're going to create a variable y, and it's going to get assigned the value of what's in M divided by 2. Enter. There we go. Now it's starting to populate for us. So we can see at a glance, answer is 15. M is 16 because we added 1 to it. Y is 18. And we're just going to keep plugging along. And we say K equals 8 minus 2. Hit the enter key. And it says, wait, you've got a problem. You didn't put the semicolon at the end of the statement. I don't have to, but for this to evaluate properly, since that's what it told me to do, for this assignment, I do have to. So if we were just doing it programmatically, and all I had to do was hit the up arrow, and it took me there, insert that semicolon, hit enter. Oh, okay, for task 5, now you're good. The spacebar through, get to task 6, use that arrow up function that I used before, go back to m equals 3 times 5. Instead of 3 times 5, m equals 3 times k. Now, we look to the right, we see m is 16. I'm going to change this to k. What's in k? 6. So m equals, instead of 3 times 5, now it's 3 times 6. And we see m changed. So these things that we're doing are updating our memory. The values being stored in memory as we go. So if we want to see what the current values are, we just glance to the right, and it keeps track of that for us. So if I want to find out programmatically what's the current value for y, I just type y, hit the correct command, and it says y equals 8, and lets us know. I already knew it because I could see it there. Let's go ahead, space bar through it. That's all we had to do. We can, if we want to, go play and test different calculations to see what happens. And it's like our little sandbox area at the end of each of these sections in this on-ramp. Plug along to the next section. We're looking at a very similar, almost identical interface, just the content is a little different. And they're saying there's rules to what you name your variables. So A is the name for a variable, and we assigned a value to it of 8. They want us to create a variable of uppercase A and assign a value of -2. Uppercase A and lowercase a are not the same thing, so they are two separate places in memory. And we see different values stored in each accordingly. Now, I can say mean of AA equals, and I'm going to use parentheses to make sure everything happens the way that I want it to happen mathematically. So I'm saying A plus A divided by 2. I just ensure that everything's happening the way that it's supposed to happen. And I hit enter. Yep, you're good. And then it populates that value in our workspace. Okay. So if I wanted to, I could create a variable, 3sq equals 9. Is that a good name, a valid name? No, it's not. We can't start a variable name with a number. So if I tried to run that, this is, well, you got a problem. So how about sq equals 9? What if I said sq3 equals 9? Will it let me do that? It will let me do that. So I can have a number, I just can't have it in the first position of the variable name. Okay, so let's keep on going. And not only are we having programming, but we've got the ability to store data in files. So we see over here that there's a file called data. There's something that we have in memory called data. So it's in the file. This is actually data. It's a matrix of the size 7 by 4, or a two-dimensional array, 7 by 4. And what we're going to do is we're going to say save, and we're going to save what's in data to data file. Now, I don't need to type in .mat. All I need is the word data file. So if I hit enter, it evaluates it, tries to do what we want it to do, and evaluates, is that what it's supposed to be? And I didn't have the .mat on there. All right, it did that for me. So it hits space. So you know what? Let's go ahead and clear our workspace. And you saw me do it earlier. I used CLC, Here I just say, give me a C, L-E-A-R, clear. And that wiped out everything over here in my workspace. So now they say, how about we load what's in file name, or whatever's in that file. So let's say load data file. So there's a data file. We don't see it, but let's assume it's in what would traditionally be over here on the left side of our workspace. In our folder organization, we would see there's a file in there. Let's go ahead and load the contents of that file, and that's what's happening in this statement. Now we've loaded what's in there. We stored data in there, and now we just went and got it. So we go ahead and proceed. We're in task 4, and they say display what's in data. Now we see that data is a 7x4 array. Well, I want to see what's in it. So all I have to do is type in the name of the variable, and it will let me know what's there. It says here, this is what you've got in there. We've got numbers, fractional numbers, and then one of the fields within this two-dimensional array has something that's not a number. Now we'll talk more about how we manipulate access to different areas within a two-dimensional array, one-dimensional array, whatever it may be. But for this, we're just checking to see what's in that storage. Now here's one that I used before. We'll go ahead and CLC. And that'll clear up the window. There we are. Okay, we can go in there and play if we want. Let's go ahead and make use of our time moving forward. Now, just like in many other programming languages, there's libraries exist to allow us standardized values, standardized functionality. So all I have to do is reference them by name, and they'll get some work done for us. So in this example, I said create a variable x and assign it the value of pi, which is represented by pi, divided by 2. So now we know if we use those characters together, they mean something. And it's 3.1416, goes out 4 precision points. We hit enter, and now we know it's going out 4 precision points is as far as we see it going. We come down, there's also a sign function. And that sign function, let's say y equals the sign of x. So there's a sign function, I pass it some value. That function returns the value we stored in y. That's basically how it works. So I don't have to perform the calculation, I have a function that'll do it for me. I just need to know what it needs from me. So we'll go ahead and proceed, and we're in task 3. There's a square root function. And they say we need to create a variable z, use the square root function, pass it a -9, and have it do what we need it to do. So here's the function, and here's the arguments that we're passing that function. Think about it like we're outsourcing the work. For many of you, this is a been there, done that, and we just got to get through it. It's easy peasy, we just do it, and it's done. So we proceed, we've got to the end of this section. We've got another video, pause mine, watch theirs, and we move forward. So now I'm assuming you've watched their video, and you're back watching mine. Now we're getting to an interface that is slightly different. And this is closer to the actual MATLAB interface, whether we're talking about online or a desktop version. Now, we have a section of code. That's what this gray box delineates. That's a section. I can create a section break and create a new section. So with that, we can run one section at a time. Let's see if this section works. Boom. Just run that particular section. It helps when we're trying to debug things, but they want us to say R equals 3. And you know what? I want to go over here and say run section. And it ran my section. So R equals 3. I submit it. It says, yeah, you're good. You wrote what you had to write, did what you had to do. I'm a programmer, I'm not lazy, I'm efficient. So I'm going to copy their text, paste it in here. I'm going to run my section again. Now my section has 2 lines, 2 statements in it. 2 variables being used, and we see both of them. What's being stored in those variables. I can run everything, clear everything, set. So this is going to run all sections, or just run one section. All right. So we've got that in. They're happy with it. And we'll go ahead and move on to the next section. So as we go, we're going to create individual little scripts in our MLX file. And each little script is our little sections of code. And this initial section, it says change it, and instead of, I'm going to go ahead and run it now. It says R is 3, and I'm going to change it to 0.5. I'm going to run it again. Now it's changed. It went out 4 decimal points, or 4 precision points, even though I just wrote it 1. It says, did you do what I wanted you to do? I think so. If I run this, it's separate. There's 2 separate sections, and I run one section at a time. Submit it. It says, yeah, you did what we wanted you to do, so we're proceeding. Okay. Now, from there, things don't always work the way we want them to work. We have typos, logic errors, whatever it is. The code sometimes doesn't work. Let's look at these 2 sections of code. And this first one says R equals 3. Let's get it underlined because essentially we haven't used it before now. And we're going to go ahead and we're going to run that section. That code's executing. Come on. It's not running. So, why is it not running? Remember I said you could put that semicolon in there. But we're a little bit better off if we don't. So if I don't put it in there and I run that section, how it ran with the semicolon in there, the way we had it, it wasn't playing nice. See it? So let's leave the semicolons out in this interface. Now down here, if I try to run this code, we see the little red squiggly line. That's kind of giving us a heads up. check before you run it. Let's say I just ignored it and I ran it anyway. Now we get this red dot with an exclamation point in it. I'm tongue-tied this morning. So it tells me you've got an issue in this section. Tells you what the issue is. But let's assume you had 400 or 500 lines of code and 30 different sections. You don't have to scroll through. You just come up to the top and it'll take you to the first error. Put our insertion point in that section. It says, hey, here's your problem. And it's having a parse error. And we know that the asterisk doesn't mean what it means in other languages. It doesn't mean that here. So we only need one asterisk. It's pi times r. Hat 2 means r squared. If we try to run that section now, I executed it. You see it running. It's taking its time. And it did run. It took far longer than I feel it should have taken. But it still did the work for us and displayed the result of what's in X over here to the right. Okay. So if I check to see, is it happy with what we did? It's saying it's having a problem with my workspace for whatever reason. These things happen. And I may have to come up here. And I'm in the debug MATLAB code section. Go ahead and refresh the page, which reloads my on-ramp. Everything should persist in there. And it should bring me right back to that section. Okay, here I am in that section. Let me go fix it. Hit submit. It says, yep, I got rid of the error. And I can get rid of those errors if I want. It's still good with it. It's still good with it. So let's proceed. And we're making headway on it. And we're going to deal with arrays or matrices. Now, a one-dimensional array, call a vector. Two-dimensional is a matrix. A single character, the way we're storing it, they're looking at it as a 1-by-1 array, as a scalar. So the terminology, we're not going to focus on that so much, but we're going to focus on how we access the different positions within it. Now, we're going to create a variable called x, and we're going to store a 4 in it. If I hit enter, it doesn't do what it did before. I have to click submit. So this is our newer interface. The only way I can run these cells is to come over and say run section. So we got through that task. We know we put a 4 in x. There's our scalar. Now we're going to say take that x and we're going to overwrite it with a one-dimensional array. It's a horizontal array with we want a 7 and a 9 in it. And then I close our braces. Put the assignment error, the assignment symbol assignment operator, x equals the assignment operator 7, and then there's a space, and 9. That space delineates another value or another index within that array. Right. So the space is what we use to create that differentiation between one index and the next. You'll see it more as we move along. So when I click submit, x was 4. Now for this cell, x is a 1 by 2 array with a 7 and a 9 in it. And it says, did you create a variable named y? No, I used x. Now, use y. And there it went. So, that got us through. Keep going. And on this, here comes that semicolon again, but we're going to do something different with it. X equals 1 semicolon 3. Well, they want us to say z equals square brace 7 semicolon 9. And I run this section, you see the difference. Now we're going vertically. So by putting that semicolon in, we're saying the next value is not going to be to the right, it's going to be below. So we said here's the first cell, and the next one's going to be below it. So we can have a column, which we did here, or a row. Similar structures when it comes to how we're storing it. It's just a visualization of it. Let's see if it's happy with what we did. Yeah, it doesn't. It's having a storage issue. Reload the page again. Okay. There it went. Get down to task 4. And then task 4, they want us to create a row vector. So that's going to be this structure, but they want 3 values in it. A 3 space 10 space 5. Close the row vector, making an assignment operator in there. Now we're good to go. And we see how it laid out to the right. If we go to the next task, let's create a column vector. Well, remember how that worked. B equals separation to make it vertical, 8 semicolon 2 semicolon -4, and then they've already closed that up for us because we have the assignment operator in there. Now when we hit submit, it'll do our evaluation for us and execute it all in one. So we see it is vertical. Go to the next task. We're to create a matrix or a 2-dimensional array. Having problems with my system today. So things don't always go the way we plan. Let's see here. Let's task 6. Let's say C equals, and we're going to do our square braces. They want 5 space 6 space 7 semicolon 8 space 9 space 10. So that's going to create the two separate rows. When we look up here, each semicolon said jump down 1, jump down 1. So it is having a problem connecting to my MATLAB. Let's see if it successfully loads this go. Okay. Let's do it again. C equals our array 5 space 6 space 7 8 space 9 space 10. Submit it. There we go, and it seems to be back functioning again. Now here we are, task 7. Create a row vector named D. So D equals, and here's our row vector with, let me just copy this. There's one value, and here's the next value. They're separated by that space. Click submit. It recognized the space. Separate them as two separate calculations. Now we're going to do our vectors a little bit differently. So in this first example, we're going to say x equals, put our brackets, we're going to say 1 space 2 space 3. Submit, and we see how it came out. Now, if we do things a little bit different, I can say y equals, I want the values from 1 to 10. And I need the semicolon in between. And there we go. Now, does it matter if I put a space in between there or not? Submit it again. We see no change there. And the next one, we're going to say z equals, and by default it's going to be a vector, so I don't have to explicitly put in the brackets, square braces. So I need to have the number I start at, which is 1. Let's look at it as where we're going to. going to go to 5. So if I went 1 to 5, if I run this, you see 1 to 5. But they want us to separate each element by 0.5. So now I come in between, and I say 0.5 and another colon. So we're going from 1 to 5, half a point at a time. I'm going to run this, and there we see it. And we see them going out 4 precision points. So it'll go run it, and it likes the way we did it. We go to the next one, and then we're going to create a row vector A, and assignment, and it starts at 3, and it goes to 13, and it's separated 2 at a time. 2, colon. From 3 to 13, separated by 2. Now this is us implicitly creating this structure. Now, what if I put a square brace there? What if I wrapped it up in a square brace? Is it going to do the same thing? Says, wait a minute, we've got a problem. But you clean that up, put it back the way we told you to do it. So if I run it again without the square braces, it runs fine. Okay. So syntax matters in this. I'm going to go to the next task, and with this, we're going to deal with linear space. And with this, they want us to create a variable called b. So b equals linear space function, and we're going to pass it the first position, 1, comma, the next position, or the end, and then what we're separating, how many elements are going to be in there. So we want 5 elements from 1 to 10. So it's going to grab 5 elements between 1 and 10 for us, or from 1 to 10. It says here's your 1, here's your 10, and there's the other 3 elements. The order's different. It's kind of similar, but not the same. It's all a matter of the tool that we want to use and how we're going to word it. So on this one for task 6, say, you know what, I want to convert from horizontal vector to a vertical vector. From a row, convert it to a column. Well, let's say we've got b. I'm going to say b equals the b that we used to have converted. So take that b, convert it, and put it in b. Let's see what it does. So here's the b we had. Here's the b we have. All I did was say, take what's in B, that apostrophe converts it to a column, and stores it in that storage space. Okay? It's not that complex. It's just a matter of remembering it for the times that we may need it. Many of these things we may not even need with what we're going to do, but we are covering them in this on-ramp. So it likes what we did. We go to the next task. So for task 7, it's going to be called C, and it starts with a 5, and it ends with a 9. And I want to wrap this up in parentheses. And it's going to be spaced by 2. Oops. It'll be spaced by 2. So 5 to 9, space it by 2. Take whatever that is and make sure that we do it as a column and not a row. Column. Okay. So let's say I just did it this way. It's a row. Take that row, make it a column. All right. So that got us through that section. At any point, if you need to, just pause this video, take a break, and come back. So we can manually assign values, or we can have the system randomly assign values to our two-dimensional arrays. So in this first task, they want us to create a two-dimensional array called X. And we're going to use the randomizer to randomly create 2 dimensions 2 by 2. And it just randomly threw in numbers. Do it again. Randomly throws numbers in there. Every time we do it, the numbers are different. It likes what we did. No, it doesn't. It wants us to do it 5 by 5. I come over and I run it. There's our 5 by 5. Run it again. Gonna get different numbers. I'll go ahead and run this. Since we're good, we proceed. Just create a variable named y. And they want a column vector, 5 rows, 1 column, assigning the result to this y. So let's go ahead and we're going to say how big do we want it to be? Well, I want it to be the number, the sequence that we're going to put in there is, say, m by n, all right, and m is our rows by columns. So I want rows first, 5. I'm going to separate it with a comma and 1. Now, they wanted it to be randomized, so I say rand. If I run that, 1 column, 5 rows. So rows and columns, rows and columns. All right. So liked what we did. Go to the next one. We're going to create one called Z. What are we going to put in it? Well, instead of randomly assigning numbers, we're allowed to put in zeros or ones. I can't put in 2s or 5s or 9s. But I can put zeros or ones. So they gave us an example of putting ones in there. We're wanting zeros. So there's a zeros function. And how big do we want this thing to be? So it says 6 rows and 3 columns. Now, I said rows first, 6, comma 3. Now let's see what it looks like. We've got zeros in there. 6 rows, 3 columns. They said 6 rows, 3 columns, zeros, named Z. We should be fine on this. It's going through doing its thing. It choked on me. I'll go to the next section. There's a video we can watch. You can pause, watch the video. We're going to actually go through and deal with the coding aspect and deal with the interface within MATLAB. Okay, so we load it up. Let's look at the interface and see what they've done. So they've got some code here that's going to set up the activity. We load a file, data file. So there's a file that exists. In that file is something called data, and they displayed the value for data. So now in task 1, they're saying create a variable x. And they want the 6th row, 3rd column from data. All right. So I say data, and the 6th row, 3rd column. Data, rows, columns. Now if I run this, it says 6th row, 1, 2, 3, 4, 5, 6. I say 3rd column. I don't see the 3rd column. Well, it's not displaying everything there. So, I had mentioned earlier, this is designed for mathematicians. Programmers are used to counting indices starting at 0. Mathematicians, they start counting at 1. Any of you that have taken COT 4400 or the algorithm analysis design courses, you start counting at 1 in those courses, because those are courses that are very mathematician driven. Even though we program in them, we look at it from the perspective of a mathematician. And that's what's happening here too. So programmers, you would be used to starting your index at 0, and on this one it would be 0, 1, 2, 3, all the way up to 6. MATLAB, we'd say 1 all the way up to 7. Takes some adjustment, but it is what it is. So let's go ahead and, oh, I did put the wrong value in there. It was 6 and not 5. So it runs through, it's happy with it. 6th column, and 6th row in the 3rd column. And now the next one, they want us to create a variable named y, and we're going to say the last row and the 3rd column. So y equals data and data, we want the row, the third column. Let's see if they're happy with that. That's it. We proceed. And the last task that we have here, we're creating a variable called z, and they're going to want, it's just really giving us fits, isn't it? The system glitched a little bit on me. So z equals data n minus 1, comma 3. So it was second to the last row. This was the last row. Here's second to the last row. And third column. So as we proceed on, we're still in the section about arrays. I'll pause while this loads. Okay, we've loaded the next one, and this first task that they want, we're dealing with a vector. So it's in this instance columns and rows from data. We want to create a vector based on that. So we're going to create a vector called density. Density is going to equal data, what we're going to get from data. We want all of the elements from the second column. So with this, I'm going to go ahead and give it the colon, comma, 2. Second column, and I want everything from it. So if we go ahead and run it, there we go. It's a column. See if it likes what we did. It says, yep, you did what we wanted you to do. For task 2, creating a variable called volumes. And they're telling us the last 2 columns. All right. So the last 2 columns is what they want. So rows and columns. And we're going to go ahead and put our text in there, colon, comma, 3, colon, 4. Okay, so the last 2 columns are columns 3 and columns 4. There's our columns. Column 1, 2, 3, 4. Now this volumes is only those 2 columns. It says, yep, you did what we wanted. So for this third one, create a variable p, and p is going to contain the 6th element of the vector density. P equals density. Get me the 6th item in there. Says, yep, you did what we wanted you to do. For task 4, Q is the vector that they want us to create. And we're getting in density. And they want us to get 2nd through the 5th element. All right. 2 to 5. And there we go. We evaluate it. 2, 3, 4, 5. And it liked what we did. And we're carrying on. So into the next section. It's loading a little bit faster this time. So we're going to create a vector v2. And we want the last column from data. Let's say data. Now, let's see if it likes what we did. I like the way we did it. On the next one, we want to change an element. So essentially what we're saying is go into V2 and I want to specifically get deep into V2 and change the value from what it is to 0.5. Now for this, there's an assumption that we know over here that it's the first element. So we're explicitly changing a value in a specific index. We're not looking for any that are not a number and replacing them. This is one specific, which is that first index, the index of 1. Bit of a lag, and there we go. So I can just say 1, and the new value is 0.5, and if I run that, we see it changed it. I submit it. Is that the way they wanted us to do it? It appears so. Now, let's do the same thing, but now we're doing it to data. We're fixing what's in data. Now, this one's a little bit different. All right. So, the way we're going to look at it is data and row 1 at the end equals 0.5. rows, columns. I just want the last column. Let's see if they liked the way we went about it. They liked it, and it did what we wanted it to do. Let's jump to the next task, next section. Alright, so we're still dealing with arrays, and you'll have a different percentage, but since I've gone through this, literally 2 different versions of this and gotten a certificate for each one, it's going to stick me with 100% because it recognized that I've completed it. Your number there should be different. So we loaded data file. And in data file is data. And let's come over here and we'll actually run that code. So we loaded it. I don't see density over here, which I'm not real thrilled with that, but the fact that we put that semicolon in there is it don't display it. Let me go ahead and do it this way. There we go. So we've got that, and they want us to add 1 to each element of V1 and store the result in a variable named R. R equals and I want to add 1 to each element. So I'm going to say V1 plus 1. Alright, so we saw what V1 is here. I'm going to go ahead and run this section. And R is 1 more for each of them. So we performed that task. We checked to see, yeah, it did like it. And we saw that it did what it's supposed to be. So we're going to create a vector VS. And now we're going in and manipulating one vector with another. So VS is the sum of, so VS equals V1 plus V2. And V sum is the equivalent of V1 and V2. Go ahead and, so 4 point plus a half and there we are. They've added them together, index by index. So there we are. We're going to the next, and they want us to create a variable VA, and that's going to be VS, the sum, divided by 2. It's performing that math calculation on each index in there. Now we're on 4. 4, we're creating VM. And that's going to be the maximum. Well, let's use the max function. And the max of VA. And that's what it wants. What is the max in VA? It is 7.4406. Go to the next task. Use the round function. So we're going to create a VR. What's in VA? We're just using the different functions that are built in. Now, I can't use multiplication symbol as it stands in this context. We've got to put a period before it. So they want us to create a variable named mass equals density period asterisk and VA. So we're multiplying density and VA. But that asterisk, it doesn't work without the period. It won't actually do the math on a vector, okay, without having that. So now I say submit. It says, oh, you got a problem. Oh, I got a typo there. That was my problem. Let's try it now. Now it liked it. I spelled it correctly. And that says we've gotten through that section. We're trudging along. I guess we're just over an hour. And we've still got more to go. So, I suspect we probably got another hour. Now, pause, like I said, and come back. Task 1, they want us to create a variable named dSize. And it's going to use the size function. And we're going to pass it the variable data. Straightforward. Tells us the size of that variable. So we're going to do something a little different. We're going to create a two-dimensional variable. Actually, it's going to be a vector with two positions in it. And we're going to call it dr and dc. And they're going to get what's in data. Now, at this point, I can go, you'll see it. You'll see it when I run it. It says, wait, we got a problem. We got a problem. What did you want from data? Oh, I wanted size. That's what I wanted. So I can't just say, well, go get what's in data and put it in DRDC. Let's go run it again. Each axis, whether it's columns and rows, and it's stored the 7 for the rows in data rows, 4 data columns. So now if I referenced dr, I run that, there it is again. It told us what dr was. So now in this last task for this section, so we're going to create two variables. One is Imax, and the other is IVMax. And they're going to equal the max of V2. So we're just getting the max of that vector. It'll go ahead and it'll store each of those values, but they're saying, wait a minute. Did I create? Oop, this one was Vmax and not Imax. There we go. So it was right, it was just a little typo. So we went and got the maximum values for each of those, stored them in two separate values. go to the next. There's a video for you. Let me pause, watch that video. All right. And now here we are. We're going to use the documentation that they give us. Wait a minute, what documentation are you talking about? Well, right here is rand random integer. If I click this, it's going to open up a new tab for me and say, hey, here's all the things you need to know about a random integer. Okay.